Astronomers initially concluded that the interstellar object designated 3 Atlas had passed safely through the solar system on a one-time trajectory and would not return. However, new analyses from researchers at Harvard University have suggested that its path may be less straightforward than first believed, and its course is being re-examined. NASA continues to monitor the object closely, though its current assessments state that it does not pose a threat to Earth. Central to the discussion is Professor Avi Loeb, an astrophysicist at Harvard University known for his work on interstellar objects and for raising the possibility that some may represent artificial rather than natural origins. Loeb is a well-established figure in the field. He has published extensively in peer-reviewed journals, served as chair of Harvard's astronomy department, and acted as an advisor to NASA. His perspective that interstellar visitors might in rare cases be technological in nature has sparked both public interest and significant debate within the scientific community. 3 Atlas has magnified this debate. The object is immense, roughly the size of Manhattan Island, far larger than any interstellar visitor previously detected. Oumuamua in 2017 and Borisov in 2019 were each only a few hundred meters across. At about 20 kilometers in diameter, Atlas dwarfs them. Astronomers had calculated that finding an object this large should be an event spaced out across tens of thousands of years. Yet here it is barely a decade after systematic sky surveys began. That statistical improbability alone raises questions. The mysteries deepen when examining Atlas's trajectory. Instead of wandering through at a random inclination, the object entered our solar system on a path aligned within just 5 degrees of the ecliptic plane, the flat disk-like region where the planets orbit. Such alignment has only a 1 in 500 chance of occurring randomly. Stranger still, its course will take it past multiple major planets, Mars, Venus, and Jupiter, before swinging toward the Sun. The probability of this sequence happening purely by chance is estimated at 1 in 20,000. To some, it resembles a carefully arranged tour of the solar system's greatest hits, not a random interstellar flyby. Even more curious is the direction of its motion. Atlas travels on a retrograde orbit opposite to the planet's flue around the Sun. This is unusual, but not impossible for interstellar bodies. However, in the imagination of some theorists, such a trajectory would be ideal for systematic study. Moving against the grain gives longer encounters and better observational geometry for anyone or anything interested in surveying planets. Then there is its speed. Atlas races through space at roughly 41 kilometers per second, nearly twice the velocity of the fastest spacecraft humanity has ever launched. This falls within the range of natural interstellar velocities, but some point out the coincidence. It is fast enough to cross the solar system, but slow enough to be tracked and studied by human technology. Loeb himself suggests that the speed appears almost calibrated for detection by civilizations like ours. Whether that is coincidence or intent remains unresolved. The Hubble Space Telescope has added another layer of mystery. When astronomers pointed Hubble at Atlas, they expected to see a familiar cometary pattern. Jets of gas and dust streaming away from the Sun, forming a tail that always points outward, sculpted by radiation, pressure, and the solar wind. Instead, they saw something altogether stranger. Atlas glowed, but not behind it. The glow appeared in front, pointing toward the Sun, as if defying the basic physics of sublimation. The absence of a proper tail, especially as the object warms, is deeply puzzling. If it is made of ice and rock, its surface should be venting material in predictable ways. The fact that it is not suggests either a composition wholly unlike any comet or a mechanism outside natural explanation. NASA officially classifies Atlas as a comet and assures the public that it poses no danger to Earth, predicting it will remain at least 150 million miles away. But skeptics point to past errors. In 2018, astronomers mistook Elon Musk's Tesla Roadster launched into orbit by SpaceX for a new asteroid until its artificial origin was clarified. If a car could briefly fool the world's experts, could an unprecedented interstellar visitor be more easily misjudged? Within the academic community, Loeb's insistence on entertaining the possibility of an artificial origin has provoked sharp backlash. Many scientists regard even mentioning alien technology in connection with astronomical objects as reckless, fearing it undermines the credibility of astrophysics as a discipline. The prevailing view is that extraordinary claims require extraordinary evidence, and until such evidence exists, speculation should remain firmly in the realm of science fiction. For his critics, Lowe's willingness to speak openly about the prospect of alien technology risks distracting from more conventional but testable explanations, and it invites public misconceptions about the scientific process. Lowe, however, counters that raising these possibilities is not about abandoning rigor, but about ensuring that science remains open to all hypotheses, no matter how unconventional, until the data rules them out. To provide a framework for evaluating such claims, he has introduced what he calls the Loeb scale, a ranking system intended to measure the likelihood of an object being artificial. On this scale, 0 represents a purely natural explanation, while 10 represents certainty of technological origin. In the case of 3E Atlas, Loeb places the object at a 4, an ambiguous middle ground. To him, the object exhibits anomalies inconsistent with typical comets or asteroids. Yet, there is not enough evidence to justify calling it artificial outright. This carefully hedged position unsettles his colleagues even more than a definitive claim might because it resists dismissal. It forces the community to sit uncomfortably with uncertainty, acknowledging gaps in knowledge rather than closing the case prematurely. The dispute over Atlas highlights a broader issue, the culture of modern academia. Lowe argues that universities have become increasingly risk-averse, structured to reward consensus and incremental progress rather than bold paradigm-shifting exploration. Research funding often flows toward projects that reinforce prevailing theories rather than challenge them. Young scientists eager to build stable careers are taught to avoid controversy. Lowe frequently contrasts this environment with the early 20th century, when pioneers such as Niels Bohr, Werner Heisenberg, and Albert Einstein upended physics, with daring theories of relativity and quantum mechanics. In that era, radical ideas were not only tolerated but encouraged, and the culture of science thrived on intellectual risk. Today, he argues a graduate student proposing a similarly disruptive hypothesis would face skepticism not only from colleagues but also from grant committees and hiring panels. From Lowe's perspective, the hostile reaction to his interpretations of interstellar objects is not simply about data. It is about institutional inertia. He views the controversy around 3I Atlas as symptomatic of a system more concerned with protecting orthodoxy than with pursuing truth. Whether Atlas is natural or artificial, he argues the scientific community should be willing to ask the difficult questions. If, however, Atlas were one day confirmed to be of artificial origin, the consequences would extend far beyond the scientific debate. The economic implications alone could be staggering. Global markets might plunge in response to uncertainty, with trillions of dollars in value evaporating overnight. Defense contractors would likely see their valuations soar as governments redirected resources into security and intelligence efforts to assess potential threats. Meanwhile, entire industries could collapse if confronted with alien propulsion or energy technologies that render human systems obsolete. Fossil fuels, nuclear reactors, even solar and wind power could become irrelevant within years. Infrastructure that nations have invested in for generations might be reduced to historical curiosities. Financial institutions would find their risk models useless. Insurance companies would have no framework for calculating coverage in a world where